Assalamualaikum and good day to everyone. My name is Khonisah Daud from UMP. So today I would like to present my research work on effects of CO2 binary mixture on pipeline performance for carbon capture and storage, or we call it CCS. Carbon capture and storage is a promising technology to reduce the concentration of carbon dioxide from emitted sources such as power plant. The component of CCS involves capturing carbon dioxide from power plant, for example, and then purify it in purification section and compress it to high pressure system before transporting using pipeline and inject to underground. Carbon dioxide stream also is not pure component. It's not pure. It actually contains a lot of impure components such as hydrogen, nitrogen, oxygen, argon, hydrogen sulfate, and etc. So in this study, the effect of impure components in the carbon dioxide stream on the performance of carbon dioxide pipeline is studied. So for the part of methodology, the mass, momentum and energy conservation equations are applied, in order to develop the model, the analytical model for the steady state carbon dioxide pipeline. So this is the mass, momentum and energy conservation equations employed in this study. So in this study also, the friction factor also along the pipe is calculated using the Darcy friction factor. All the properties, pressure, temperature, density and so on of a carbon dioxide stream is actually calculated using Penn-Robinson equation of state. The analytical model is actually developed using Plato software, in Plato Fortran software. For the result discussion, in this paper, actually the simulation results are presented into two parts. The first part is actually the impact of impure components on carbon dioxide phase diagram is studied. As we can see in figure, this is pressure, temperature, phase diagram. As we can see, the black line is represent for the pure of the bubble and dew point line curve for pure carbon dioxide. So as we can see, the presence of impure components is actually change or affect the vapor liquid equilibrium of carbon dioxide. So for example, this is for a binary mixture of 10% volume per volume hydrogen and 90% volume per volume carbon dioxide. The addition of hydrogen in this mixture actually change and lift up the bubble point curve of the vapor liquid equilibrium curve. So as shown in the figure, the impure components like nitrogen, hydrogen, oxygen, hydrogen sulfide, argon, and carbon monoxide in carbon dioxide stream has slightly less impact on both bubble and dew point curves. Thus, it remains the gap closer to the pure carbon dioxide saturation line. However, the presence of hydrogen is clearly shown that there is a significant difference in bubble point line between the vapor pressure of pure carbon dioxide. The second part is actually the impact of potential impure components in steady state carbon dioxide pipeline flow is studied. As we can see in figure 2, the corresponding simulated fluid pressure, density and velocity variation along the pipeline is studied. So the black one represent for the pressure drop for pure carbon dioxide, and the brown one represent for the binary mixture of carbon dioxide and hydrogen sulfate. But the red line is actually represent the pressure drop along the pipe for binary mixture of hydrogen and carbon dioxide. So as we can see in this figure, hydrogen actually gives the highest impact in terms of pressure reduction in the pipeline compared to other carbon dioxide stream. So all properties profile for carbon dioxide mixture, for example, for nitrogen, oxygen, argon, and carbon monoxide, are always in between the binary mixture of hydrogen sulfate and hydrogen sulfate and hydrogen stream. So in the case of carbon dioxide binary mixture contain hydrogen sulfate and carbon dioxide, the reduction pressure is almost the same with the pure carbon dioxide. So as for the conclusion, the presence of hydrogen in the carbon dioxide mixture stream is actually shows the most affected in performance of carbon dioxide pipeline. Shows the most impact on the properties on the properties profile in carbon dioxide pipeline. Thank you.